Okay, let's get started. So this workshop is about dashboarding. It's called we're going to be creating a dashboard using Power BI. My name is Jessica Lam, and I'm from the Bureau of Contract Administration with the City of Los Angeles, Department of Public Works. And as my TA, I have Eric Lai from Bureau of Engineering, also from Department of Public Works, City of Los Angeles. And today's February 1st. Okay, and we'll just go straight into it. This is a very short PowerPoint presentation, and then we'll go into reviewing the sample data set that I provided to everyone. We'll be looking at Bureau of Contract Administration's payroll data. At BCA, we collect a lot of payrolls from a lot of contractors to monitor their wages and basically all the workers and their hours on public works construction projects. So it's a lot of data. A few million rows of records, but I pared it down to be just year 2018, and it's a really nice, clean data set to work with. Okay, so first off, who's my audience? Are you confident with Excel? Are you great with programming, but are you rusty with programming but great at understanding logic? Or can you write code in a few programming languages? Like, can I get a show of hands? The first one, confident with Excel? Okay. Rusty with programming, but great at understanding logic? Okay, that's good. Who can write in a few programming languages? Excellent. Great. Okay, so next, So you're asked to create a dashboard from upper management, but what is it? So a dashboard is an information management tool that's used to track key performance indicators, metrics, and other key data points relevant to a business, department, or a specific process. And Power BI will help you get there. So let's continue on with the basics. How can I make one? How do I start? First, you want to look at the existing reports that your organization is responsible for. Look at what you report on, what's important to track, what data do you collect, which reports take up most of your time creating, and lastly, what are your business rules? That's most important when you're trying to create a report for your end users to use, whether it may be for the public or for your everyday analysts to use and to make their lives easier. So to do that, we're going to use the systems development lifecycle. This will help you move forward with developing your reports in a way that is very structured. So you can use that to your advantage. What is the systems development lifecycle? First off, there are 5 phases. This is a very simplified version of the SDLC model. The first one is requirements analysis. And in this phase, this is where you talk to your end users and you figure out what you need. You want to talk to them and ask them, how can we make your lives easier? What are you responsible for doing? Like, what is it that's required in your job that you would like to be done better or automated? And secondly, it's design. That's the second phase. Design phase is where you make a plan. You talk about amongst yourselves, if you have a team, how you're going to help your end users achieve their goal. And the third phase is implementation. That's where you build whatever it is you're building, your report. Fourth phase is testing. This is where you test for bugs. You want to make sure that your report is running smoothly and that your end users can access your report. That's super important. The fifth phase is evolution or maintenance. This is where your report goes into production. And when your report goes into production, you may find that your report has to evolve. As users' needs change, your report will evolve and you may have to start the whole SDLC cycle over again. So you might be back at phase 1 where you reevaluate what you need, what your end users need, and in turn, what you need to design. So it's a cycle that you can use to your advantage and that you can use to structure your project. So your project as in creating the report. So yeah, it's a project management tool for you. So Power BI lets you implement all these phases in a very quick way where you get quick results. And if you find that you need to tweak something, you can go back into any of these phases and fix it. And then you go back and put it into production. Okay. Feel free to stop me if I'm going too quickly or if you need additional clarification. Okay, so here's a real life scenario. I have been asked by upper management to create a dashboard for Bureau of Contract Admin to monitor project labor agreements on public works construction projects. So there's so many business rules to be considered here. So project labor agreements are, think of them as like affirmative action for hiring local workers. So on public works construction projects, the idea behind project labor agreements is that we want to not only create nice buildings, bridges, everything for the local community, we also want to empower the local community by hiring them. That way the local community can be proud of where they live. They can look at a bridge and say, I worked on that. I helped construct that. So that is the purpose of a project labor agreement, reinvesting back into your community. So for PLAs, we require that contractors meet the following hiring goals. 30% of all their total hours have to be done by have to be completed by local workers. We split up the City of LA zip codes into 2 tiers, Tier 1 and Tier 2. Tier 1 is the more disadvantaged zip codes, and everything else in the City of LA is Tier 2. And that'll be important when we look at the data set later, so just keep that in mind. 50% of all your apprentice hours have to be done by local apprentices. So of all your apprentices, how many of them came from Tier 1 and Tier 2? 16.67% of all your straight time hours have to be done by apprentice workers. So straight time is hours less than 8. 8 or less hours. That's straight time. Anything else would be considered overtime. And lastly, 10% transitional hours. That means 10% of all your hours have to be done by transitional workers. These are workers that are disadvantaged. They may come from a low median household income. They're typically in poverty. Okay, so there's a number of criteria. It's all listed in the project labor agreements, but for now, let's just move on. Yeah. And next, the data set that I have provided for everyone is really cleaned up and nice, but I'm going to talk about how data is usually organized just to give everyone a bit of vocabulary to work with. That way, when you look at your own data set, when you go back to your office, if you have a relational database, you'll know exactly where it's coming from and why things are the way they are. But for the purposes of today, the data set that we're looking at, it's already been denormalized. What that means is that all the records that we need, it's all in one table. I didn't want to work with multiple tables and have you guys merge or combine tables together. But Power BI does let you do that. It just takes more time and understanding to get to that level. And I do have a few resources in a Google Doc that I can share with everyone afterwards. So data is usually organized where you have tables, rows, and columns, and each one represents an entity where you have values attributed to each one. So for this table, I have phone products. I have the product name, iPhone 7, when it's released, and the price. We made these up. I don't really remember how much a Samsung Galaxy cost in 2018, but that's like just a simple data table. Next, most people or most organizations work with a relational database. A relational database is a collection of related data arranged into one or more tables with a unique key identifying each row. So you're going to have a bunch of different tables, and each table is related to another table by keys. So on the left, we have item ID, order ID, the item, and the amount. And then that is related to the bottom table where you have the order ID and the customer ID. So that the bottom table tells you that for that order, you have that customer and they ordered on that date for that amount. And then the right table, you have the customer's information. So it's very fragmented, but it's very efficient because you have data stored in just one place. That's the purpose of a relational database. It minimizes the amount of space that you need to store your data. So that's why organizations use it. But in terms of data analysis, it's easier if you just have everything in one table. That way, if you do aggregate functions like add up all the hours in one column, you can do that without having to go through multiple tables to get something like that. Okay, so tables in relational databases are usually normalized. That means your data is saved in one place, usually as much as possible. Normalization refers to fragmented data tables. It reduces data redundancy and improves data integrity. So it means that your it should be accurate, and true. A denormalized table, however, contains most of the data that you need. That's what we have today. And a data dictionary is one that you have to understand your data. Where I uploaded the data set, I do have a data dictionary there, and we'll review that in a bit. And you can make a data dictionary just to help you understand the data when you go back to your office. So tables are usually related by relationships, much like how one person has just one social security number. This is called a one-to-one relationship, where one entry in one table is related to another entry in another table. That's called a one-to-one relationship in a relational database. One-to-many refers to one entry in one table associated to many entries in another table. So you have one museum that has many works of art. Many-to-many relationship refers to multiple entries in one table and that are related to multiple entries in another table. So you can have books written by many authors and many authors who write many books. Does that make sense? Yeah. Okay, so how can Power BI help with all of this in terms of relationships and all this data that you have? It helps you in that you can create really quick visualizations. You can automate your current reports and deliver high impact. So when you have all these crazy relationships going on, you can use Power BI to sort of mock up what you need. So you can go back to your systems person, your database administrator, and you can tell them, I need a view that has all these fields so I can do data analysis in Power BI. So that's what I've used Power BI for. And that's later in the resources document. And so let's go ahead and make a dashboard. You will need a Windows machine. So if you don't have one, pair up with someone that does have one. Sorry, Mac users. You can download Power BI if you haven't already. You can just Google Power BI. And then for your sample data, oh my goodness, did I? Hang on. So you can get all these instructions in the School of Data schedule. Hang on, it's signing me out. So if you go to the schedule, you can navigate to it easily by going to schoolofdata.la and then scroll down to the schedule part and then click on their hyperlink where it says draft schedule doc. So you're good? You got it? Okay. Okay. Yeah, it is kind of big. So I'm gonna break for a little bit and help people or like see where everyone's at. Okay. Yeah. So just go to this draft schedule doc, and then you're gonna arrive here, and then go down to my course where I think it's like page 8. And then the instructions are here. Please install Power BI Desktop, and the links are here. And then you're gonna need to download my data as a CSV file and follow along with the DAX code right here. So just open up these links, Power BI Desktop. It's going to look like this. So you're gonna download it, go to details. Wait, hang on. Never mind, just hit download. And then you're gonna choose the whichever one fits your computer. So for me, it would be the 64 one, and then hit next. Yes. Okay, so raise your hand if you're done downloading Power BI Desktop. Okay, people still need help. So it sounds like everyone's good. Okay, so next we'll go ahead and download the data as a CSV file. Just go ahead and go to it and then hit open up my link. It should look like this. And then you're going to hit export and then choose CSV and just download it. It'll take some time. It's a lot of data. I'm going to review my data set soon. And then on another tab, you're going to need to open up my Google document for the DAX code. We'll be copying and pasting my code into Power BI. So just have that open. Looks like that. Okay. So for my data set, I have a lot of variables. I mean, a lot of fields. I have 170,000 rows and 31 columns. Each row represents a worker's hours for a company on a City of LA public works construction project. So it kind of looks like this. There's a lot of data, but I'm gonna go over each one just so you have an idea of like why things are important. So payroll detail ID, this is a unique identifier for each payroll record. For every payroll that comes in, for every worker on every company, it gets automatically assigned a payroll detail ID. For each worker on a payroll, they get a payroll worker ID. So that it just identifies each worker for each payroll. PLA type ID. This is where we differentiate between the different project labor agreements. So for City of LA, we have quite a few project labor agreements. We didn't stop at just public works. We also deal with POLA. POLA stands for Port of Los Angeles. LAWA, Los Angeles World Airports, they also have project labor agreements on their projects. So, but for the purpose of today, I filtered this data set to only have Department of Public Works PLAs. So PLA type ID 1s and 6s refer to Department of Public Works. 1 is the older PLA, the 6 is the newer one. So PLA agency refers to the agency in charge of administering the PLA. So for us, it would be City of LA Department of Public Works for this data. Next is PLA year. This one is the contract agreement, like during what years is this PLA in effect. So for PLA type ID 1, that would be in effect 2010 to 2015. So for projects with a bid date between those years, it would fall under PLA type ID 1. For PLA type ID 6, that's in effect during years 2015 to 2020. So that's the PLA year. And then for PLA tier type ID, this is where we have the different set of zip codes. So for us, we took the entire list of City of LA zip codes and we broke it down into 2 tiers, tier 1s and 2s. And just remember that tier 1 would be like just a set of City of LA, the targeted zip codes, and then tier 2 is just another set of City of LA zip codes. That's what it refers to. And then prime work order number. This refers to the work order number associated with each project. So if the end user, like an analyst, wants to look up a project, and if they have the work order number, they can just type in a work order number and they can get the information that they need that way. Project key. This is an internal project key that we assign to every single project that comes into our database. Project title, the name of a project. Project status code. This is like if a project is active, accepted, or like closed already. That's project status. Company key, and then company name, worker ID, state code. State code refers to a worker's state of residence. Zip code is a worker's zip code. Council district, a worker's council district. Week ending date refers to the payroll week ending date. So for City of LA, we get our paychecks every Wednesday. I mean, not every Wednesday, every other Wednesday. So yeah, it's just like a payroll week ending date. Daily date refers to a day that a worker worked. So if you were filtering for payrolls, like within a certain time frame, you would want to use daily date. Work class ID refers to like job classification IDs. work class description is the entire name of a worker's job title. Trade is the different trade categories that the job falls under. Apprentice level refers to like different apprentice levels because these are construction jobs. Workers have to go through an apprenticeship program before they reach journeyman level status. Job status is, are they a journeyman or an apprentice? Is apprentice is just a true false field. Risk ID is 0 means non-target, 1 is disadvantage. Disadvantage is the disadvantaged worker term associated with the older PLA. 2 would be the transitional worker term. And then standard hours worked refers to almost like straight time, but it should be under 8 hours. That's what we had before as straight time, but then due to business rules, we also count in foreman hours. So foreman hours are if a worker is almost like a supervisor, they work as a foreman too. So those hours are counted. And then all these OT hours are OT at 1.5 rate, or OT at double time, or OT at triple the rate. And then daily total hours is all these hours added up together for that payroll record. And that's all that I have for my data dictionary for today. So let's go ahead and open up Power BI. So just open it up. It takes some time to open. And you don't need a license or a pro license as far as using Power BI desktop, but you will need a pro license if you were going to share something. Like if you created a dashboard, a really nice report, and if you want to share it with someone, you will need a pro account. But for purposes of today, we don't need to go there. So if you have this window, just go ahead and click on already have a Power BI account, sign in, and then hit the X. We don't need to sign in. And then if you have this window, go ahead and click get data, or if you closed it already, that's fine too. You can also get data here. Just hit get data. And then go down to text/CSV. And then you're going to navigate to wherever you saved my sample data set. So for me, it would be in the downloads folder. And it's this really long title that starts with Bureau of Contract Admin. And then you're going to open it. Okay. Okay, now let's go ahead and hit the edit button right here at the bottom. And we're just going to make some minor modifications to my data set before we import them in. So on the left is a list of all your tables. So for right now, we just have Bureau of Contract Admin and this really long title, right? So let's go ahead and change that. Let's change this thing to say you can just click into it and my data and just call it that. It's I think it's case sensitive, so just copy me. Yeah. And then if you notice, on the right, we have a list of steps. So whatever you do to your data to transform it, it'll automatically log it. So that'll be useful if you're trying to figure out what you did or how you got to a certain place. So here, we need to change this one to be a data type whole number. Right now, it's set as a type text. This is the PLA tier type ID. We need to change this to be a type whole number. So click on the ABC right there, and then go to whole number. Okay. And then it's going to ask you, are you sure you want to change the column type? You say yes, replace the current step. And then, okay, next, if you want, you can take a look at this data. This is like everything that I've described to you. It's just a lot. We'll just leave it. It looks good to me. Yes. Oh, you can click on, you go to PLA tier type ID. Oh, wait, Eric, please help him. Yeah. Raise your hand if you need help. Like, yes. Sure. You go to PLA tier type ID, and then whatever icon is there on the left, you're going to click it, and then go down to whole number. Before it was set as a text. The type was a text field. And then you're just going to change it to be a whole number, and that'll be important when we're programming in DAX. Certain DAX functions only like certain data types. Yeah. Okay, are we good? Yes. Okay, so now the next step would be to create a local table to display your last refresh. So that'll be useful for when you're sharing your report, or if you're creating a report and you want to know how current is your data, like at what point when did you import your data? So that's always useful for reporting purposes. And to do that, you go down to new source, click on new source at the top left, and then go down to blank query. And then you're going to go to advanced editor at the top. Just click on that. It's it's like right here, advanced editor. And then you're going to delete whatever's there. Just highlight it and delete it. And then go back to my Google document. Hang on. Oops, sorry. Okay. Okay, go back to my Google document, and then you're going to copy and paste this code right here. So go to my DAX code document, and then you're going to look under the section where it says query editor M code. You're going to copy this part. And then you're going to paste it in your advanced editor. So delete whatever's there, and you're going to paste it, and then click on done. And this code is creating a table where it's going to display the date and time that you last generated this table. So every single time you hit the refresh button, it's going to display the time and date that you hit the refresh button, and then hit done. And so the time right now is 2:41. And that's the time that this table was generated. And then you're going to hit on close. Wait, actually, before we do that, we're going to change this table name to be last refresh, like that. Yeah, change it to be called last refresh. I believe I called it underscore local. Let me see. Change the name to be this, last refresh underscore local. And then hit close and apply. Is everyone still with me? Yes. And now it's applying all the query changes that you've made to your table, to your two tables. It might take some time. Okay, so let's go ahead and copy and paste some code and create some interesting visuals. Okay? All right, let's go back to the Google document. And we're going to go to the second page where it says last refreshed. And this code right here, it's going to display we're using a concatenate statement where we're stitching together a string and the date that we last refreshed. So that's what this statement is doing. We're going to copy, and then we're going to go back to Power BI Desktop. And then on the right, you're going to click on this little arrow next to last refresh underscore local. Click on that. And then right click on the table and then go down to new measure. Measures in Power BI are calculations. These are, this is where you can type your code. And then when you hit new measure, this is something will pop up that will say measure. And then, oh wait, hang on, I lost it. New measure. And then at the top, there's a formula bar where you can paste it in. So delete measure equals, and then just do like a control V and then hit enter. And it looks very much like Excel, where you have a formula bar at the top and you have all these interesting buttons that you can play around with later. And now you have a last refresh measure available. And we'll go ahead and use the card visual to display this last refresh date. So go to the card visual right here. It looks like this. Just click it. And then you can either drag it into the fields section, or you can just check it off and it'll pop it in there. So right now it's telling us that this data is current as of today, February 1st, 2019. And last refresh right here is the name of the measure. So that's being displayed. In order to make things look a little bit nicer, we can remove this. We can hide that. That's not necessary. So go to the format button. It's a paintbrush right there. And then you're going to go to category label and then just toggle that off. And the name of the measure will disappear. So it was on and now it's off. We're using the single one. Yeah. Multi-row card, it would just be smaller. You can put more measures into it. But for now, we're just using the single one. Oh, in order to get a new measure, you just right-click on the table that you want to put the measure in. So right-click, and then go down to New Measure. And then from there, you're going to delete whatever's there, and then paste in your code from the Google Doc for the last refresh measure. And just like as a future reference, if you have a measure with the same name, it's not going to let you. So if you were testing things or like debugging your code, and if you wanted to test how things might work out, you might want to call things like last refresh 2 if you wanted to try something different. And that way you won't run into errors. Okay, are we good? No? No, I'll help you. Yes. Okay, so I see that some people are a little bit confused here. So what we did, I'm going to go back to edit queries. So earlier when I made the last refresh local table, what this table contains is the date and the time in which you last refreshed. So in this case, it's the date and time that we generated the table. And this measure that we have here called last refreshed is concatenating a string that says data as of, and it's stitching it together with just the date. We're dropping the time because I only want it to display data as of and the date. Does that make sense? Yeah. And comments are denoted by two forward slashes, and you can read my comments there. So if you notice the first section, does everyone see the three little icons on the top left here? The first one is the reporting section. This is where we're creating our report, creating all these nice visuals. The second one is where all your tables are all located at. So this is where you can explore your data. And if you click on that, it shows you, it brings you to the first table, the last refresh local table. And then if you go to my data on the right, this is my huge sample data set. So that's there. And then the third one refers to relationships. This is if you wanted to connect some tables together using primary keys. This is where you can use your knowledge of one-to-one, one-to-many, or many-to-many. And you can read more into it later. So we'll just go back to the reporting section. This is, I'm just going over this so you know how to navigate around Power BI. Okay, so we'll just leave this in the corner. and we'll pop that in filters section. We don't really need that now. And then we'll go on next to back to my Google Doc. And we're going to count the total number of workers in my data set. So just go ahead and copy this. And this is doing a distinct count of all the worker IDs in the table called My Data. And then you're going to copy, and then you're going to do the same thing as you did before, but in the My Data table. So you're going to open up the My Data table, and then you can right-click anywhere, and then go to New Measure. And then you're going to paste in the total workers code, and then just hit Enter. And it should show up right there. And we can use a card visual as well, just to display what's there. So over my whole data set, I have 3,802 workers. And this, we're doing a distinct count. So if a worker appears multiple times in my data set, they'll just be counted once. That's what distinct count means. I clicked on card right here. So hit card. And then from there, I chose my measure that I just created. You can either drag it into the fields, or you can simply check it off and it'll populate in the fields section. That's by default. So you can change the visual by just clicking on it and just choosing something else like that, or you can, yeah. So it allows, Power BI allows you to switch and interchange between different visuals very easily. Yeah, that's one advantage it has against R versus R. You have to program everything down to the axis, down to the colors, all that. This is a little bit easier. Only problem is you have to program the calculation part. That can get a little complicated. Okay, I'm going to remove one of these because I have two. So to remove a visual, you can click on it and then click on the three dots and just hit remove. So I had two, I'm going to remove one. Going back to my Google Doc, we're gonna now add up all my hours. So total hours, just copy, paste, right click, new measure, and then paste it in. So this measure is summing up all my daily total hours from the My Data table. And daily total hours, as I said before, it's a sum of all the hours for a payroll record. So we're adding up standard hours plus all the overtime hours plus the foreman hours to make daily total hours for a worker's payroll record. Yes. Yes, you can also do that as well. But I'm just used to typing my code this way, which is why I did it this way. But if you wanted to, you can, of course, be grammatically correct and capitalize your first word and with the space. It's just that when I was making this presentation, I copied and pasted from my actual report, and that's how I programmed it. So it was just easier to get it this way. Yeah. But of course, aesthetically, you can do that later. Yeah. So just hit enter. And we're gonna go through like, I think I have like 12 or 13 of these. So percent local hours. This measure is doing we have a variable called local hours in here, where we're calculating the total hours that we created from before, right? This was the measure before, total hours. We're summing up all the daily total hours, and we're using it in this variable right here to calculate local hours. So local hours is hours worked on by tier 1 and tier 2 workers. So we're calculating the total hours for which these tiers are flagged as 1 or 2. So calculate, what this is saying is calculate this for which PLA tier type ID is a 1 or 2. These two straight lines represents or. So this calculate function is just saying do that measure from before, but filter it for PLA tier type ID 1s or 2s. Yeah, does that make sense logically? Yeah. And then from there, save it in a variable called local hours. And then we're going to divide by total hours to get the percent local hours. So here I have an if statement where I only want it to do that calculation if the total hours and total workers is greater than 0, because what I've found through working with this kind of data is that some contractors and their accountants, their payroll entry people, they've been using our payroll system as a sort of balancing tool where they would input negative hours and it'll just throw everything off. So that's why I'm accounting for those instances and just filtering out those negative hours. I don't want negative hours in my data set or in my calculations. And same reasoning with total hours. I just want to make sure that I'm only working with positives here. Yeah. And then here I have a, so if everything is positive, then do this division where I'm dividing local hours divided by the total hours and then rounding it to the second place. And then I'm adding a 0 because if a company does not have local workers, it's going to return as null. It'll return as blank. So this part will be blank, and in DAX, blank plus 0 equals to 0. So if they don't have any local hours, I want it to show up as 0 in my later visuals. So that's the purpose of the 0. And keep in mind we have this if statement thing going on. An if statement is if something is fulfilled. So if I'm working with all positive hours and positive workers, then do this calculation. Otherwise, return as blank. Because if it's not positive, just return as blank, like don't even show it. Yeah. So that's how I'm calculating percent local hours. And I'm going through all this, and I know all this might not be relevant to anyone because it's applied to Bureau of Contract Admin's payroll system, but I think it's very helpful to learn about how to calculate or sum things up conditionally. That'll be useful if you want to count things like based off certain criteria. So that'll be good for you to learn. So copy that, and then we're going to paste it as a new measure in the My Data table. Okay, so we're creating all these measures, but we haven't really done anything with them yet. Let's go ahead and create a table just so we know what's going on. So click on table right here. Make sure you're not clicking into any visuals first. Just click out of them if you have. and then select table, and then you can drag this out to make it a little bit bigger. And then, do you see the values section right here? This is where you can drag in different things to look at. So let's bring in project title. All my data is all about projects. So I have a whole list of all my projects in my data set. And then let's bring in my percent local hours. So just hit percent local hours, and then it'll show up to the right. I'm gonna make this a little bit bigger. It looks really small. So to make it bigger, just make sure you're selecting that table, and then go to the paintbrush, and then you're going to go to values, and then increase the font size. So I'm gonna make mine size 14. Is that big enough? Yes. Okay, so size 14, and I'm also going to change my my column headers to be bigger. So I'm gonna like pop this back in, and then go to column headers, and I'm going to also increase the text size to be a little bit bigger. So size 15. So on the left, I have project title. On the right, I have percent local hours. And something like this is super impactful for upper management to look at, because now you can go to them and tell them, I have a whole list of all the projects in year 2018 and how they've performed for local hours as far as meeting that requirement. Yes, any questions? Yes. So, okay, is everyone still with me? Okay, so now we have a whole list of all these projects and like how they've done for percent local hours, right? And it's rounded to the second place because that's what I asked it to do. So we can change this one, percent local hours, to display as an actual percentage. Let's go and select that measure. And then you're going to go to, I think it's modeling tab. And go to the modeling tab, and then you're gonna hit percent in the formatting group. And then from there, you see that it's now adding a percentage sign to each of my numbers. But we have zeros. Zeros are not necessary, so I'm going to change this to be a 0 for the decimal places. We've already rounded to the second place, so it's okay. Yeah. Yes. Go to the modeling. First, make sure that you're selecting the percent local hours measure. Okay, and then go to the modeling tab, and then click on percent. And then from there to the just to the right of it, you're going to change this number to a 0. It was a 2 before. Okay. All right, so let's go back to my Google Doc. And then we're going to copy this next one, percent apprentice hours based off total hours. So what this one is doing is a little bit different than what I had before for percent local hours. We're still using a variable. I'm calling it local apprentice total hours. A little bit wordy, but I wanted to be more specific. So we're using the calculate function where we're calculating the total hours measure from before. And instead of just saying, I want to filter by PLA tier type ID 1s and 2s, we're looking at apprentices. So we need to be more explicit and actually tell it, filter my data, that table that we're working with, for these filters. So I have an AND function. So filter the my data table for apprentices. This is where I'm using the is apprentice field for true values. So if it's true, it means that that person was an apprentice for that payroll record. So filter for apprentices and for PLA tier type IDs 1s or 2s. So we're using an and or function within that filter function, and then we're using those filters to calculate total hours. So it gets a little bit more complex there. And then the second variable that I have is called apprentice total hours. This is what we'll be dividing by, and we're calculating, again, total hours for which the payroll records are only for apprentices. So calculate total hours for only the apprentice records. And then we're doing the same thing. If total hours and total workers are greater than 0, then do that division where we're dividing local apprentice total hours divided by all your apprentice hours, rounding it to the second place, and then adding a 0, and then else return as blank. So it's the same logic as what we had before. It's just a little bit more complex, but it's the same idea still applies. Okay. And once you get into this, you'll find that there's a pattern to all this. It just looks a little bit hard when you're, it looks hard when you're first looking at it. Yeah, it takes a little bit of time to wrap your head around it. Yeah. So we're gonna copy that and then go back into here and then new measure and paste it in. And then hit enter. And then we're going to, if you notice, this measure is pretty big, so this whole formula bar area expands. You can pop that in by clicking on this little caret here. And then click on this table visual that you have. And then we're going to bring in the local apprentice measure that we just created. So we're going to check that off, and then it'll be right here. And you can see over all our projects, we had 61% local apprentice hours. So we met our goal. That was really good. And we're going to do the same thing. Make sure that you click it, and then we're going to add a percent to it. So change it to percent for formatting, and then remove the zeros. So just change this to a 0. Okay, and then going back to my Google Doc. Now that you're all experienced with creating measures, we're going to create a calculated column. So this calculated column, I'm calling it sum of standard foreman hours. So here I have if standard hours and foreman hours added up together is greater than 8, set that max. I mean, set it to be 8. Otherwise, return the sum of the two. And this is what the Bureau of Contract Admin defines as straight time. Straight time is defined as the sum of the two, but if the sum of the two is greater than 8, I only want it to show up as 8. So this will be a calculated column, and it's not a measure. So just copy that, and then go back into Power BI desktop, and then you're going to right click and then go down to new column, and then you're just going to paste that in. And the difference between calculated columns versus measures is that if you have a calculated column, that means for every single record, it's going to do that calculation and it'll save it in your table, versus a measure, it'll calculate it on the fly whenever you need it. But that's the main difference behind it. And not only that, measures deal with aggregate sums, aggregate functions. So in this case, I want it to do it for every single payroll record that I have, and not just on an aggregate level. I want it to do it for every worker on every day for every company. Yeah, so that's why I'm using a calculated column instead of a measure for this one. So I'm using a calculated column in this case because I want it to do this logic for every single record in my data set. I don't want it to just do it on an aggregate level. I want it to do it for every record that I have. It's calculate columns means that it'll think of it as like an appendix, like it's going to add as a new field to your table. So it'll go to every single record. I have 170,000 rows in here, and it'll add a new column and do it. When you have a measure, measures will calculate on the fly, like as you call them, as you bring them in. What we had here with percent local hours and percent local apprentice hours, those are measures. So those get calculated as we drop them into visuals and use them, versus calculated columns, it'll do that calculation whenever you hit refresh. The refresh button is at the home button, and then click on home, and then if you hit refresh, every time you hit refresh, it'll go through all your queries that we did before and your calculated columns, and it'll do all that and then save it on your RAM, on your local machine. So that's the difference behind measures and calculated columns. Does that make sense? Yeah. Okay, so now that we have that, let's go back to the Google Doc. And then we're going to look at percent apprentice hours straight time. So this one, we are calculating the apprentice straight time for apprentices. So we'll be using the calculated column that we made previously, and filtering for apprentices and saving this calculation in a variable called apprentice straight hours. And then we'll be dividing that by total straight hours. So we're just doing a sum of the straight time in the My Data table, and then returning it for total straight hours greater than 0 and total hours greater than 0, and then dividing it. We're dividing the two, rounding it to the 4th place, because the state labor code is very specific as far as apprentice straight time hours. They want the target is 16.67% of all straight time hours have to be done by apprentices. And there's a little bit of buffer, but because they're so specific, that's why we're rounding to the fourth place instead of to the second place as we did previously. Otherwise, return as blank. So that's how we're calculating percent apprentice hours straight time. And then pasting it in. As a measure, not as a calculated column. And then we'll be adding it to our table that we have here. So just make sure that you have it selected, and then you're going to check it off. And then if you drag the little scroll bar at the bottom, you can see where it is. It's right there. And we'll be changing it to show as a percentage. So just click it and then go to modeling and then hit percent and just leave it as 2 for now. And then you'll see why in a bit. And then just bring that in. And since we rounded to the fourth place, it's very accurate. It tells you down to the fourth place. Okay. Okay, so next, percent disadvantage or transitional worker hours. Just copy and paste that. This is it's calculating total hours for which your risk ID is 1s or 2s. The 1 refers to disadvantaged workers and the 2 refers to transitional workers. Only difference between the two are the PLA years. The older PLA calls them disadvantaged, the newer one calls them transitional. That's why we differentiate between the two, between the two, 1 or 2. So we're doing the same logic. Make sure that we're working with positives, total hours and positive workers. And then we're dividing the 2 and then rounding to the second place and adding a 0. Otherwise return as blank because I don't want to see them if they don't have any. Okay. And then you measure. And then hit enter. And then and you're going to bring that into your table. And also, okay, so we brought it into our table. And it's right there, percent disadvantage or transitional worker hours. And then we're also going to format it to have that percent sign. So just click that and then change it to be 0 right here. So now you have a table of all your projects over year 2018 and how they've done as far as hiring goes for every single category that we require contractors to meet. So something like this is very powerful. Upper management, they love this. They're probably watching me now too. But this is powerful, and it also lets the public know that we're doing our jobs. And you can export this data. Just go to the 3 dots up at the top. And then you can export it as a CSV for future data analysis in Excel or wherever. So just hit export and it'll export as CSV and you can save it wherever. This is if you were doing ad hoc reports and if you wanted to send it to a council member's office or to the mayor's office, you can do quick and dirty data analytics and then just send it out through email. Like they wouldn't need Power BI to get something like this. Okay, so that's the first page. Next, oh wait. Okay, next we'll do the fun stuff. Hang on. Okay, let's work on pasting this one and then we'll work on putting in a scatter plot. So copy the number apprentice workers measure, and this is doing, this one is super easy. We're just doing, if we're working with positives, positive hours and positive workers, then calculate total workers for which we have apprentices. So just copy that. And then make it as a new measure. Hit enter. And then go back and get the next one. Apprentice total hours. We are doing, I'm getting the total hours for apprentices only. So just copy and new measure for that one. And then hit enter. So for this one, let's use these two. The first two that we made, apprentice total hours and apprentice workers. And we're going to choose the scatter plot scatter chart. So just click on that. Make sure that you're on a new page because otherwise it'll look too cluttered. Just hit the plus at the bottom to make it page 2. And then you're gonna drag this and make it a little bit bigger. And then from there, you're going to go to daily date right here. And then you're gonna drag it into your, wait, I think you can just click it. So click it, just check it off, and then it'll populate in the details area. And you should just have like one dot in the middle. And then next, we're going to put in number apprentice workers in my x-axis. So number apprentice workers, it should be your second measure. Just check it off, and then it'll bring itself into the x-axis area. And then next, we're going to check off apprentice total hours. And it'll bring itself into the x-axis, and you can drag it into the y-axis area. So in this program, you can drag and drop almost anywhere. If it doesn't work out, you'll just get an error message, and you can try again. Okay. And then from here, if you notice at the top, there's this drill down button. Like these buttons are really fun to play with. You can, the first one is grayed out. It's the drill up button. The second one is drill down. This is if you wanted to like zero in on a certain dot and like look more into it, you can click on that. This one goes down to the next level in the hierarchy, and but the one that we're going to use is this one, expand all down one level in the hierarchy. So hierarchy in Power BI refers to this date hierarchy that I have. Daily date is, there's a hierarchy to it. Like on the top level, you have year, then you go down to quarter, then you go down to month, and then you can lastly break it down by day. So that's your date hierarchy. When you import fields, it should automatically identify by hierarchy. So you have that. So just click on expand all down one level in the hierarchy. And then if you see here, it now brings it by year and by quarter. And then you can click on it one more time, and then you get more and more dots because you're expanding by year, quarter, and now month. And then if you keep going, you get more and more dots because now it's getting it down to the day level, where you have year, quarter, and now year, quarter, month, and then down to the day. So it's plotting every single day like that. Yes. Yes, if you had more granular data, then you can drill down as far as like your hierarchy is set. Yeah, but for this purpose, it's just like that. Yeah. So if you notice, like this scatter plot, it looks a little bit odd to me because at the bottom we have apprentice workers, and then on the y-axis we have total hours. I'm going to make this a little bigger. Go to the format button. Wait, how am I doing on time? 3:30. It's almost time. But you can adjust the axis. You can change the. Okay, hang on. Y-axis. You can change the font size like that. It's really easy. And then go down to y-axis, and then you can also change it there. And then, so here I have like two different groups. On one end, I have a lot of workers and they're doing not that much work, not that many hours. And then on the other end, I have a lot of workers and they're actually doing work. But keep in mind, we're looking at apprentices. These are not experienced workers. So with the state, there's a mandate where you can't really have too many apprentices doing all your journey level work. That means you're underpaying your workers. So that may be a reason for why we have two different groups here. Yeah, and it also depends on what trade you're looking at. Like it really varies. Yeah. Okay, so I'm just gonna quickly move on to the next visual and show you how to cross filter these visuals. So next, we're going to make a pie chart. So just click on pie, and then we're going to bring in job status. So just bring in job status. You can drag it into the legend area. And then we're going to get our total workers. So just find where you have total workers down here. And then we're going to bring it into values right here. And next, we're going to bring in total hours and then put it in the tooltip section. So here, I'm going to make this a little bigger again. So paintbrush, and then I think it's the details label. And then we're going to make it bigger. Okay, there. So here I have a pie chart where I have apprentice workers. So my values, I have workers and I added in total hours. So if you hover your mouse over this, it'll show you not only their workers, but also their hours. But this is actually a little bit confusing because if you're looking at this, you don't know what exactly is being highlighted. Is it hours or workers? So if I was designing this dashboard, I would actually remove one of them. So you know that that slice only refers to workers and not hours. So that's it for this part. And as I said earlier, you can switch between different visuals very easily. So you can just select this visual and hit copy, Control C, and then you're going to do a Control V. And then we're going to change this to be a matrix. So make sure you have it selected and then just hit matrix. And then now we have the same information, but in a matrix format. I'm going to make this a little bit bigger. Go to row headers, size 14 or 16. And then values. And I need row headers to be bigger as well. So that's that. And I'm also going to bring in my total hours because I didn't have it up there in the pie chart. So make sure you have this this matrix selected, and we're going to bring in total hours into our values section, and it'll show up here. So here we have total workers and total hours for apprentices and journeymen broken out for you. And if you wanted to cross filter, you can do that. Just hit apprentice and it'll cross filter your whole page for just apprentices. And If you notice, if you choose journeyman, this one is blank because it's only doing apprentice calculations. We only put in apprentice measures in there. So that's why this one is returning as blank. And this one, the pie chart is now lit up for only journeyman. So that's a good example of cross-filtering visuals. Okay. And lastly, let me just go over slicers really quickly so you know how to slice and dice by things. Filtering is very important as far as like day-to-day life for analysts. There's a slicers button. You just click on slicers, and then you can drag in like fields like company name and just put it into fields. And then now you can check off like any company. If you wanted to look at stats for a specific company, you can do that. Right? Or, yeah, so just on your own time, play around with these visuals. They're very easy to use. The hardest part of Power BI is the calculations part, figuring out the logic, but once you have that down, it's more of just using it, like just knowing that syntax. And I have a whole list of resources that I can give you. This code is also available to you. You can get down and look at them. If you have any questions, feel free to email me. Here's my email, and there's Eric's email as well. And now that I got the Power BI, you all have it as well. Yes. And then this list of Power BI resources, it's also, I believe I sent it to Vicky, but I can also send it to you if you email me. And it's just a list of Power BI resources. Things in yellow that are highlighted are the important ones. If you want to get your feet wet and just get a crash course in Power BI and how to code and everything, I do recommend going over them. They are pretty good and comprehensive. So all this is here. If you want to change like colors and stuff, there's things on maps and like colors, and formatting is also here. So there's a lot of good articles and resources available to you. Okay. Okay, yes, that's my email.
Thanks again.
Okay. Thank you so much. Yeah, you're welcome. Good.
Awesome.
Yeah.
Yeah.